Hello and welcome to assignment 6 of topic 6, first video in which we will tackle the first function, and this exercise is mainly about functions handling arrays. So we are asked to implement several functions. I'm going to focus on the first one, extreme, and extreme searches the smallest or largest element in an array, and since there's a possibility of two, so either the smallest or the largest, we will need a second optional argument deciding whether to pick the smallest or of course the largest. Okay. Take a look at the tests to see how we verify functions. Okay, so let's do that. In the extreme case, just to see how the default value is handled. So if we have an array like this, the minimum seems to be taken out by the function extreme if no second argument is given. If, however, the second argument is false, we find the largest one and not the smallest one. So the second argument has to be false in order to find the maximum. Otherwise, if it's true, or by default it's true, then we get the minimum. So let's do that. We need a function extreme. Extreme. Let's go into take in some array. Okay. And we'll need to find minimum, which is of course by default true. So if no second argument is given, then it will by default be handled as true, which will mean we'll find the minimum. So what we'll do is move on and write a function now. We need to check all the elements in the array to find the smallest one. So let's assume that, well, I can do it like this. If I need to find the minimum, then I need to go about it like this, and else I'm going to have some, well, pretty identical code, I guess. But let's just write it for now. So finding the minimum would be, let the minimum be the first element in the array. Okay. And then we'll need to go over all the elements in the array. And of course I can skip the first one. Okay. So let's start at the second element being index 1. Because the first one we're going to assume is the minimum, okay, unless we find something that's smaller. And we go to the end of the array, meaning all indexes or indices smaller than array.length. Here we go. And if we see that whatever number we're looking at the moment, so array at position I, is smaller than, don't mind the AI trying to be smart here, if it's smaller than the minimum, then my minimum will be, my new minimum will be, of course, that array at position I. So that's a classic way of finding the minimum. We're assuming the first element, so the element at index 0, to be the minimum. We tackle all indices from 1 because we already assumed 0 being the minimum. So all the others from 1 to the array length. So meaning if the array is 10, we have 1 all the way up to 10 not included. So 9, because a length 10 array will have indices from 0 to 10. 0 is assumed to be the minimum, and we're looking at all the indices from 1 to 9 included, so to 10 not included. And if I find any element in there that's smaller than the minimum, that's going to be my minimum from now on. Okay, so I'm kind of dragging along the minimum while I'm aiming for the end of the array. And I can do the same for the maximum. So if I need to find the maximum, I can call it the maximum. And of course, the only thing I need to do is find something that's bigger than the maximum. Okay. Watch out when copying and pasting code. And of course, I need to, after this for, I need to return the minimum. And in the else case, after the for, I need to return the maximum. So let's see what the tests say, and that seems to be okay. Now, let's see if we can clean up the code, because we have some principles, right? Dry, as a reminder. Dry, meaning don't repeat yourself. So don't repeat yourself, meaning that we cannot have duplicate code in there. If it's identical, we either collapse it into a loop if it's identical and right after each other. If it's in different places, we are going to surround it by a function and take it out, put it in a function, and at any position where it was, we're going to call the function. And then we have, so we're going to solve this with loops or functions. And if the case where it's not identical, okay, we're going to revert to the previous case and make it identical by introducing variables. Okay. So the part that's variable in the two almost identical cases, we're going to take out, put in a variable. The variable name will now be the same in both cases. And we have identical code that we can take up into a function, and of course the variables will be the parameters then. Okay, we'll watch this in real life as we do it. And then the other principle is a single responsibility principle. Okay, and that's mainly about having one single purpose or responsibility for a single piece of code. And of course, the single pieces of code we're going to focus on from now on are functions. So the rules of thumb here are we will have only maximum 6 to 7 lines of code in a function. Although if it's longer than that, probably you have more than one responsibility and you have to split it up. We will have maximum, or at most 3 parameters. If you have more, probably you need to pass around information as objects and no longer as single variables. And maximum 2 indents. Sorry. So an indent is something like this. I have one indent here. We're not taking into account the indent for the function itself. So we have one indent here, and we have one indent there, and we have a third indent there. So that's already too much. Okay, so maximum 2 indents. And these are the rule of thumbs. The rules of thumb. Sorry. So let's see what's happening here. We have 2 parameters. That's okay. I have way too many lines of code, and I have more than 2 indents. That's of course because this code and this code is basically doing the same thing. So what I could do is I could either split it in 2 functions, one finding me the minimum, one finding me the maximum. So I could do it like this. Function minimum for an array is going to give me the minimum, and that's going to be this piece of code. Okay. And then of course I'm going to return whatever the minimum of that array is. Okay. And in the other case, I'm going to have a function maximum. Okay, of an array, which will give me this code. Okay, that's almost the same code, but not just yet the same code. Okay, because of this, and of course the variable name would be the same, so I could call it element. Okay, and then the only thing would be this, returning the maximum here. So we cleaned up this code. Let's first see if the tests still run. Okay. Seems to be okay. Now, can we deal with this a little bit more? I have only one parameter here, 2 indents, so the indent problem is solved in this case as well. In this case, only 1 indent, 2 parameters, but I still have, well, the 6 to 7 lines is also okay. 1, 2, 3, 4, 5. I don't count these lines. So that's also okay, but still, so on the SRP level we're good. On the drive level you might say, well, this looks quite like the same thing. Okay, so perhaps we might turn the function into something like this. I'm going to give it another go, see if we can do better, but well, we're already pretty good here. But I'm going to do this then. And what you could do is say, I'm going to find both the minimum and the maximum. Okay. So let's assume the first element both being the minimum and the maximum. And then I'm going to run over all the elements there. And I can do like this. I'm going to have the 2 ifs at the same time. Okay, so this is less optimized because it's doing too much work in either case. If we're looking for the maximum, we don't need to find the minimum, and vice versa. Okay, but let's see if we can clean it up like this. So we're kind of now balancing between optimizing the code and readability and optimizing the code and speed. Okay, so now I'm diverting from speed, going to more readability code. So perhaps we can prevent these two cases of being almost the same and well, being used repetitively, because that's violating dry. Okay. So then I have to decide here. So if I need to find the minimum or the maximum, I need to do it like this. Return minimum, otherwise return the maximum. Okay. And you can see that by doing that, we'll get to much lines here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. I'm not counting the else's and the empty lines. Okay, but still, it's too much. I have 2 indents, which is okay. First of all, I can clean it up a little bit by not needing to have all these empty lines, because it's a fairly easy thing to read. Okay, so this is just checking if it's smaller than the smallest or bigger than the biggest. In either case, you have a new well, you either have a new maximum or a new minimum. And I can do this without the curly braces as well. Okay, there we go. Voila. And I probably can write this for loop a little better. You have for off and for in, which are basically cases of what we call for each, but the syntax still is a for. Okay, so you have for let the element of the array be something. Okay, and it's either in or off. Okay, so in will let the element take all the indexes in the array, so 0, 1, 2, 3, 4, and so on. Off will give you all the values in the array. So for each element of the array, each value of the array, I'm going to check if the element is bigger than the maximum or smaller than the minimum. Okay. And in that case, I'm going to assign the element either to the maximum or the minimum if I found either one. In the other case, nothing's going to happen, and I'm going to the next element. Okay. He's nagging about an unresolved variable of or type L, so I guess I need a let. Okay. So I don't know why he's nagging about this. Let's just first try it out. Okay. Let's see what's happening. And there we have it. Exception during run of this. What does he say? Legal return statement. So this can't be there, and of course that's because I forgot the curly brace. Okay. And now we have green tests again. Okay. So well, this is quite readable. It's tackling the two problems at once, and I have 1, 2, 3, 4, 5, 6, 7 lines of code, but well, let's call this all one line because of the fact that it's quite readable. It's very easily readable, so I kind of get away with it. Okay, so you can either solve it like this, which is very fine, but then you have dry. Okay, and I can clean up these pieces of code as well because I don't need the curly braces. Okay, it's quite readable like this. There we go. So, but still, it's violating dry because this is basically the same code. Okay, and if you would make it the same by changing the variable name, so you could call this extreme, and then this would be extreme, this would be extreme in both cases, so the code would be identical then, except for the less than or smaller than. And that would, of course, if you want to solve this, have to be taken into one function with a Boolean argument deciding whether to have the smaller or the bigger. And well, that's exactly what happened here and what I did here. Okay. But there's no point in having the if in here. So I could split these two, but then I would tackle or try to tackle many problems at once. It's better to just have a go at it. I'm doing too much ifs, I know, so it's less optimized, but it's quite readable. If it would be so in the light of optimizing, I would say optimize for readability first. And if it's an issue on the side of speed, then you might think about changing the code, even make it less readable to speed it up. Okay, so work in that direction, not the other way around. And that's it for my extreme function. I'm going to run the tests one last time to see if everything's okay, and it is okay. So I'm going to leave that here just for that educational purposes, but we basically don't need these two functions because I just kept them all together in one function. Okay, that's it for the first function in assignment 6 of topic 6.